Hey everyone, welcome back, and today let's solve Leetcode problem 2 titled Add Two Numbers, a very classic problem of linked lists on Leetcode. So I'm not going to lie, I was pretty shocked when I realized that I haven't actually solved this problem yet on Leetcode. It's a very good problem, and also I don't think I've solved any linked list problems on this channel yet, if any, and so I thought it'd be a great video to go over. So we're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. We need to add the two numbers and return the sum as a linked list. And we may assume that the two numbers do not contain any leading zeros except for the number 0 itself. Okay? So they give us a nice image to actually visually depict how these linked lists would actually work when we sum their values up. And we'd output a list of 708 because 342 plus 465 is equal to 807. In example 2, we have the linked list to be just 0 and linked L2 to also be 0, and so we simply output a sum of 0. And in example 3, we have the following values, and we'd output this, the sum of these two values. Okay, so with that out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so how can we efficiently solve this problem? It's quite a straightforward process. We have to traverse both the linked lists simultaneously, and we have to do this while adding corresponding digits along with a carry from the previous sum. Okay, so we'll use two pointers initially to traverse each of the linked lists, and we'll also have a separate integer variable for the carry to monitor the carry for each sum. And a dummy head is also going to be initialized for that result linked list to actually kind of simplify the code and avoid kind of handling special cases for that head node. And we'll also use a pointer to keep track of the current position in the result linked lists. Okay, so with that out of the way, let's just go ahead and dive straight into the code here. So like I usually have for linked list problems, I know this is probably my first linked list problem on this channel, but usually I'll have a dummy head. I'll just call it dummy head, and it's going to be initialized to list node. Oops. With a parameter of 0, right? We have to create this dummy head node to actually kind of just simplify the linked list manipulation, where this node, or this dummy node rather, kind of just acts as a placeholder to which we'll essentially append our resulting nodes. Okay, so we'll set our current to actually be equal to that dummy head. Right? We just want to set a pointer current to that dummy head, which will help us build the new linked list as we actually add the numbers. And we'll also initialize our carry to be 0, right? Which is going to keep track of the carry from the addition of the two digits, right? So now we have to have our main chunk of code here. While L1 is still valid, or L2 is non-null, or we still have a carry. Okay, so while there are actually nodes left, either in linked list 1 or 2, or there still is a carry, we want to set value 1, okay, the value for the first linked list, to be L1.val, only if L1 is non-null. Otherwise, we simply want to set it to 0, right? We have to retrieve the value in the current node in L1, but if it's none, we have to set it to 0, which is going to handle the cases where the lists or rather the linked lists are of different lengths. Okay, and we'll have a similar approach for val2. It's going to be initialized to L2.val, but only if L2 is non-null or non-none. Otherwise, we want to initialize it to be 0, kind of defaulting it to 0 if, again, L2 is null. And we'll set our current total to be equal to val1 plus val2 plus the carry, right? It's going to simply be the sum of val1, val2, and carry to get the cumulative total. Okay, and now we'll update carry to be equal to the total divided, again, integer division by 10, because that's how simple addition works. We have to update the carry to be the tens place of the total, right? The result of the integer division by 10. And this is going to determine what we actually need to carry to that next digit. And then from there, we can set current.next to then be equal to list node, passing in the total modded by 10. In Python, it's simply going to be parentheses, similar to many other languages as well. We have to create this new list node with the ones place of total, right? The result of the modulus operation of 10, and we have to assign it to the current.next node, which is effectively going to append the new digit to the result linked list. And then we have to set current actually equal to the next node. So current.next, right? Just setting this current pointer to that newly created node to actually continue building the result linked list. Okay, so now we have to check if L1. If L1 is valid, we need to set L1 equal to L1.next, right? If L1 is not null, we can advance it to the next node for that next iteration in this while loop, and we'll have the exact same thing for L2. So if L2 is non-null, we want to set L2 to also be the next node. So L2 dot next, right? Only if it's non-null. And ultimately, outside of this while loop, we simply have to return the dummy head dot next, right? Because we have to return the linked list starting from the node after the dummy head, which is going to give us the resulting sum without that placeholder node, okay? So unless I spelled something wrong here or made some weird syntax errors, this should be accepted and it should be a valid solution. And as you can see, this is just about as efficient as you can get. For some reason, it says I only beat 30% of users because I have a 7 millisecond runtime. Probably if I were to run that again, it would update to like 0 milliseconds. Okay, yeah, so it got a lot faster. But yeah, it's effectively the most efficient solution that you're going to have. So what is this going to do overall? Okay, to kind of summarize what our code does, we have to take first two linked lists that are going to represent numbers, and we have to add them accumulatively, digit by digit, using that carry to return a new linked list that's going to represent their sum. And we also have to effectively handle cases where the lists are of different lengths, and we have to account for carries during each addition of both nodes in each sum. Right. So for the time complexity here, this runtime complexity of this solution is going to be big O of the max of m and n, where m and n are the lengths of the two linked lists. Why is that? Because we traverse both the lists until we actually reach the end. And so the space complexity is also going to be the maximum value of m and n, again, their lengths, since we're actually creating a new linked list that could be as long as the longer of the two input lists. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.